So it's problematic having a secure social web here. All right, thank you. All right, let's see how fast we can get going. In fact, in any case, I'm going to skip a bit of the demos, given that this was, but there's going to be a hacking session where we can do some more exercises there. So I just present myself quickly, kind of places. I started learning computing on a Digital Equipment Corporation when I was a kid. In the early 80s. That got me into a little bit of AI, Lisp, and then I thought philosophy, so I ended up studying philosophy at King's College London. And then I ran out completely of money, so I ended up on the street pretty much, squatting and trying to live a philosopher's life. And I remember that I could do some programming, and then I earned a bit of money. I said, wow, it's like in 2 weeks I can get as much money as I had for a whole 2 years of university studies. So I got back into that, but I was always keen to get back to my philosophy. And in fact, I think we found the road. I'm going to show you a little bit how this works. So we can start off with an interesting, this is a really good TED talk by Matt Ridley called When Ideas Have Sex. It starts with this great analogy that the size of a stone of the Stone Age man and the size of a mouse are the same. Technologies are completely different. The stone from Stone Age man, before starting 1 million years ago, for about 800,000 years, the tools didn't change, and human beings changed faster than the tools. At some point, language came in, and the stone tool could also be made by essentially one person. And then we come up through the Greek period, through the discovery of writing, through which Socrates and Plato were dealing with, this huge technological change of alphabetical writing, which meant that the memory that was transmitted by poets before started being transmitted through stone engravings. This is also what gave us democracy. And we come all the way through the printing press, to the machines, to this mouse that has the same size, but which has lasted perhaps 10 years, had a 10 years existence span, but which nobody can make. Nobody knows how to make the mouse. And in fact, there was an artist in Britain at the Academy of Art who tried to prove this. He started off from this quotation from Mostly Harmless in Douglas Adams' book, where I think Ford Perfect lands on a planet somewhere with so-called primitive people, and he thinks he's going to rule the world, and this planet, with his high technology, and then he realizes he doesn't know how to do anything. In fact, he can hardly make a sandwich. And so this artist, Thomas Thwaites, decided he's going to try to make a toaster from scratch, just to prove that he could do it. And then he went for a £7 toaster in the shop, took it apart and found about 200 pieces in it, right? So that he was already a bit... So this is another great book to read. He then went off to put this into different types of metals, group them together, and then he went to an ore company to get some iron ore, and then he read some old books from the Middle Ages, because that's about the only thing he could do to smelt this stone into something metallic. In the end, he used a big machine, a highly complicated machine to do it, because he didn't have enough time. But in the end, he ended up with this, and it lasted about 1 minute. So the thing is that in both of those talks, they make the point that this complexity of technology depends, the complexity of the technology we make depends on the size of the community that makes it. Certain types of technologies just can't be made in ancient Greek village town cultures. We need global systems to be able to build and be able to deal with the problems of our time. And those are really beautiful designed ways. So that means that creating social networks is very important, right? It's not, the problem is how you do it. And so this is the wrong way of doing it. This is a great picture from The Economist from 2005, I think, 2006, which shows exactly what's wrong with the current social networks. They're siloed, they don't speak to each other, they're centralized, they're panopticon-like. That is, you're inside of them, and the owner of the data sees everything, and you can only see a little bit. You can't communicate with other people, and what happens in this type of system? Well, the biggest system wins. And that's the same with television. Once you have a biggest system that wins, you also get the worst quality, right? Lowest common denominator. So what we want is we want to get out of this. We want to get out of this, since we get out of prison, we can get out of all of these problems, so that we all have our own social networks. Now, if we just go a little bit back in the past, we'll notice that it's a bit weird that we end up in these social networks where you can only work with people in the social network. When we had the telephone, you can call someone from France to Germany, or from Germany to England, or United States. All you need to know is the number. You don't need to know their provider. You don't need to know if they're BT. You can just connect across any type of network. All you need is a telephone number. That's a global identifier for the next telephone, right? Email, which was a technology of the 70s, allowed you to do this type of communication too, across companies, across universities. And it also works with this global identifier. And so what I'm trying to get at is the importance of the global identifier is key to all of these systems working. So when we start looking at the web, we have the same thing. Machines have global identifiers, right? On these machines, you can put an HTTP server, you can give names to each of these documents, and then you can create linked documents. And what we want to do is we want to create linked documents that speak about people and things in the world. And if we can do that, then we can create a distributed social web. So, in order to do this, we start moving towards philosophy a little bit, because this is the project that Tim Berners-Lee has been working on since about 1993, 94. He had his first slides at the WW 2014 conference, where he started the idea of the next generation web. This came out in about 2001, the first RDF specs, which were taken on by Firefox, Netscape at the time, which was a massive disaster. It was just too early. It takes time for technologies to mature, for people to understand how they work. And especially this technology, as it's really, in some sense, philosophy applied to the web. Tim Berners-Lee, that's a quotation from Tim Berners-Lee, is that the web is now philosophical engineering. So I'm going to show you a little bit how that works. Let's just take, for example, a URL, a simple universal resource locator that identifies a web page. Here, Le Monde, a very serious French center-left newspaper. The URL refers to some resource which is deemed to be unchanging. You could think of it as a four-dimensional space-time continuum. And it has states, different pages of the web over time. And this is that change. And the question is, how people often ask, it's kind of a philosophical question that comes up, is how do we know that this URL is going to refer to the same type of thing in the future as it did in the past? And the simple way of explaining that is this is social binding that's happening. When you publish a web page on the web, and I publish a blog, and you link to my blog because you like it, the value of my page goes up because there's going to be one more link to my page, one more way of finding it. And the more people link to my page, the better. And the more I avoid changing the link and the meaning of my page, the more value this can get. And so this is a social system which works like most of our social systems through conventions that stabilize, that meta-stabilize, as they say in philosophy. That is, that they can change, they can move, but very slowly. The whole system as a whole is stable, but the parts are moving in a fashion that the whole thing doesn't collapse. So the first web is this very simple URL that refers to documents. The second web, the semantic web, is just going to play a little trick on this, and it's going to have these two URLs here. So we have the URL, which, and this is Tim Berners-Lee's, what we're going to call a web ID. The big red box is his web ID. The first URL here is pointing to his profile that you can download with a curl or web. And this contains a graph of information, just some bunch of relations. And you know everything by looking at it like this. They're just various syntaxes that you can have. This here describes Tim Berners-Lee uniquely in some way, right? And so we have these relations. Each URL refers to something. The URL without the hash refers to the document. The URL with the hash refers to Tim Berners-Lee. The URL with a hash, the sense of the URL is this document because it describes him. And this is, in fact, what you find in philosophy. So when Frege started, there was a big jump in philosophy from Aristotle, who who, I don't know his logic that well, but there was essentially for 2,000 years until Frege in the end of the 19th century started mechanizing logic, there was nearly no change at all. You know, Leibniz and Boole came in the 19th century, but with Frege you started having a mechanized logic. And of course, it's very interesting that mechanized logics are going to be really interesting in a computational environment where we have machines that can process these types of things. So we have documents and they can speak about people. And what we need to just think about is, so it's called the semantic web, it's also called linked data. There's those two elements. Just the distinction between syntax and semantics. Syntax is just strings, how they tie together to form sentences. And semantics is how these strings relate to the world, right? If I say I am at Orm 2013, the words that come out of my mouth are certain sound patterns, but I am physically here in this Orm, and I could be anywhere in Orm and still the sentence be true. But what's interesting about this as opposed to SQL and other types of databases is that these URLs, these identifiers are URLs. And this means that as opposed to SQL, when you come with an SQL query, there's no way of if you go in a global context of knowing what the query means. If you can give a universal resource locator to your relations, to your identifiers, you can always click on those relations and get a description about what it's about. So for example, if you don't know what that relation in the middle is, http xmls.com/0.knows, you can click on a document, and then you get a web page. If you're a human being, it will give you a web page. If you're a robot, it might give you RDF XML that describes what a person is. And it's really quite obvious, right? A person is a person. This is giving a little bit, saying a little bit more is kind of obvious. It's the intuitive notion of a person. Don't put too much in it, and it ties it to some other notions that are defined there. You could have this in Japanese and in Chinese and in German. The same page could return different representations depending on your browser settings. You can have classes of things like this, fourth person. So you can have a global naming and database system. So I was going to give you a demo. And of course, my computer's been switched, so I can try to describe it to you. We wrote quite a few of these demos, and we're going to show some this afternoon. It's very simple. You can, in one of the best ones I like, you go to a web page, you drag and drop Tim Berners-Lee's profile onto a little JavaScript. So we're just writing a JavaScript application. You just load into your browser. It's completely empty. Has a few panels, and you could drag and drop Tim Berners-Lee's web page onto your panel. It would go and fetch the RDF remotely, and then fill in all the information. And then you could find out who his friends are, click on that, and find information in a panel like the Apple address book or the GNU equivalent. You'd have a column showing all the friends. You can click on one of the friends, and it will go and fetch his information from his web page. And then his web page might have information about him, which can show you, which you can see in a little, perhaps his picture, his name, his address, and so on, his work, his hobbies, and you might find a list of his friends, which you can click on. So everybody keeps on their server, ideally, everybody would keep on their server at home a web server that would keep the information about them, their friends, and so on. So sadly, I don't have a demo of this because it was so, as you know, changing these computers around. So the web is peer-to-peer in that sense. You can go from one page, follow links, go to another page. You can have robots do this. And I had a little demo of this in Java about 6 years ago, which I presented Java 1. And people would say, really great, amazing. But where's privacy in there, right? Because all of these documents are completely open to the world. So you could follow one link, and that information would be public. And so people are saying, well, on Facebook, we get all this protection, right? We get protection because we can show information to only some of our friends. And I'd argue, well, yeah, but you're showing some of your friends, but you know Facebook, and now we know a bunch of other people also know the information. But they have a point, right? So if you want to share some information with some people, you need access control. So why would we want to implement this kind of thing? Well, if we want to get people off Facebook we have to give them the same kind of features that they enjoy on Facebook. Perhaps they want to publish a picture of when they went to a party and they just want their friends or the people in the picture to see it, right? So we need to get the same kind of features. And well, I don't know how much time have I got now. Where is it? 31. Okay, good. So what's happening is imagine I made this great demo and you were all clapping. And now we come to explaining a little bit how this works. You have these different servers, web servers, as boxes here. This would be your Freedom Box. This would be my Freedom Box. And this would be Tim Bray's Freedom Box. And this would be mine, which you have at home. You have a web page that describes in some kind of format relations between Tim, in this case, and, for example, that he knows, this is a prefix, that he knows this person referred by this URL, which if you dereference it, you get to this document, right? So that's why there's a link from here to here. And here you see this information. And of course, it's much easier to explain if you don't need to learn about that syntax. That's called Turtle. There's a bunch of other syntaxes. In fact, any type of data format can be transformed into this graph pattern. So you can see these relations. And then you have your JavaScript, in the case of the demo we were going to show, that goes and fetches the data, places them in a store with names, and then potentially adds a bit of metadata for where it was fetched, when, so it knows it can go and fetch new versions. And then it merges this information, because the semantic web is just a very cleverly simple system to merge information from different sources. So if you know about mashups, the semantic web is just the formalization, the mathematical formalization of how you do mashups. And once you have two documents meshed up, you have more information than when you have them separately. So, because you can then add reasoning, right? So in this case, for example, you knew that he knew this guy, but if you only look at this, you don't know his name. But if you look at this one here, you know that he knows him, but you can follow the link back to finding his name here, Tim. So you have more information. You can get further in the graph. And, all right, so this is how you do reasoning in this system, right? So I was getting back to the problem that we still have the problem of authentication. And for this, I started looking at 5 years ago at OpenID. This was kind of very complicated. So we discovered a very simple way of doing authentication that uses SSL, and this is kind of a jujitsu move on SSL. We're going to do some Aikido on it, because usually people think of SSL as a CA-based system, where you have to go to some certificate authority, you get your key, and we get rid of all of that, because we don't sign, we have any server sign your key for you. We still have a problem about your own server needing to deal with SSL for the moment, but we're hoping Dane can deal with it, and then there might be a way of doing this over I2P and other systems, which, if anybody here is good at I2P or DNSSEC, Tor, sorry, then it would be great to hack some things together at that space there. So, where are we here? Creating a public key creating a key is very easy. I think I have a demo here in this thing here. Did I does this thing come out as a? I should have put the video up. Well, that's why I had this these slides. So there's an HTML. All right, let me go back. Sorry. Creating a key creating a key on a browser. People say this is difficult. In fact, it's as easy as for the user as clicking one button, because there's this HTML keygen tag that's now in HTML5, but that was in Safari, Firefox, and Chrome since 2000 or before. And it's kind of not very well documented, and there's Microsoft has this other ActiveX version, but you can hack around these. And what happens is that when you create a form like this, the browser will create a public-private key here, send the public key to the server, and the server can just sign the public key. And the interesting thing is put your web ID in the subject alternative name of X509. So when I discovered this, I didn't know anything about SSL, but there is, in fact, a spot in the X509 certificate to put a URL in there. So it creates this, and this server, nobody knows who it is. It's Bob's web server, some web server. He signs this certificate, sends it back, and the browser automatically adds it to your key store. And all the user needs to do is click one button. And then what your server should do is, at the same time, publish the public key in your profile. You say there's an RSA public key. It says that you have a cert key and gives you modulus and the exponent. So this is what we're working at the WebID incubator group at the W3C. We've shown that you can implement this in about any possible language. And then when the user comes to some other website, completely different, and clicks on a login button, this type of thing will appear. In fact, this doesn't appear, but if you want more information in Chrome, it will give you more information, and in there you will find your web ID. So now you imagine going to some website. What happens is you go to some website, the guard will look into its access control list. I'll show you how that works later. If you need access, it can do certificate renegotiation and ask you for your certificate. Then it looks at the certificate and finds the public key, does a get on your profile, and if the exponent and modulus match, it knows that you are now identified not just by the public key, but by the web ID. And if your social network says that you are authorized to view this resource, then you get access. Now you have distributed access control. This is good. Most browsers on operating systems, commercial operating systems, work quite well. On Firefox and on Linux, they tend to have pretty bad user interfaces, but someone one day will fix that. As I said, there's problems with this. You know, if you still say you still need CA on the server, but there's DNSSEC that's hopefully someday is coming along. I think it's moving ahead, and there's DANE, which allows you to do a public key in DNSSEC. So there's possibilities going out that way. But the most interesting is that you can do robots that start getting information like this. And then finally, we were speaking about access control. And so we've been running a web server that does some kind of fun things at that level. If, say, you have that profile and you have a link ACL header in the header, HTTP header, so every document comes with a header, that's pointing to this ACL. This can also explain which types of resources get access to it, which class of agents, for example, they can be defined on a different server. This server can name, can say the members of that group, that's a FOF group, by naming people on different machines. And this could be quite nested, right? So you could have groups on, you could even mention, it doesn't have to be one per these slides. You could have a bunch of FOF groups that you give read access to. In this case, it gives this group write access, and it has a C also link to find something like this, perhaps, which gives read access to any agent whose URL is under that namespace, right? And if you use this, for example, if you're programming in Scala, for example, this gets it's really possible to do this very efficiently, because you can do all of this asynchronously. You can get one of these documents asynchronously. You can write this in such a way as you're completely agnostic as to where the data is. You have different agents for local storage and remote storage. Some agents will do HTTP gets, others look at a file system. Make very clean code, so that you can build the framework for doing this. And so we have this already, and this evening or this afternoon, I think at 8, we can play around with that. As I was saying, we have, if there's I2P or Tor specialists, we get some really fun things, because I know for Tor for sure there's onion URLs, and you could have an onion web ID, right? If there's, I'm not sure, right? I haven't tested it, but I think, Jacob Appelbaum told me in the CCCB a year ago that he thought this was possible. So now you can have weird things. You can have HTTPS web IDs, and you could link to your Onion friends in Tor, who could link to your I2P friends, and you could have distributed, anonymized social networks, right? So what do we need? I think we have the code. We have a bunch of different groups, some people doing some stuff in JavaScript. I'm doing in Scala, others in C. There's a whole bunch of different people on the, I think if you go to W3C Web ID, or if you follow what we're doing here at Stample on GitHub, you'll find all of those projects and hopefully links, and you can email me. Really, if you're fed up with centralized social networks, I mean, stop complaining, right? This is, you can fix it. The technologies are there. It's all standard based. I mean, there's a couple of things we can formalize a bit better as we get used to it. But it's just a matter of doing it. And then you'd have completely encrypted distributed social networks. And, well, if people want to store, if the government wants to store for historians, I don't know how long time it would take them to decrypt this stuff, information about what we're doing, well, all right, we can deal with that. But we're already much better off if our information is distributed, as the intent was meant to be, as a distributed system. So there's no one big brother with completely asymmetrical power over us, right? So if you know people who can code, or if you can code, or if you're interested in, some of this doesn't really need coding. There's JavaScript, there's lots of JavaScript libraries where you can do everything JavaScript, you can do things in RDF. I didn't mention the linked data protocol, which is one part that the, one protocol that the W3C with Oracle and IBM, I'm representing Apache, are working on, so that you know what happens when you post some RDF or some picture to a container. Think of it as AtomPub for RDF, for the semantic web. So that's just being standardized right now, but it's pretty simple, all of this. So we can already do a huge amount. And the more we are, the faster we'll have something that's just absolutely unbeatable. Because this network is going to be the social network. There's not going to be any other social network after what we've done, right? It's like there's no two webs, there's the web. And so what we want is to build the social network of the future, and I welcome you to join us to do this. Thank you very much.
Any questions to the speaker? I have at least one that I wanted to know. So you're talking more about designing a new social network, right? Do you have any thoughts on fixing the current ones or incorporating them into this infrastructure so that we don't lose what we already have?
Yeah, that's a good question. It's completely feasible. I'm not going to go. I mean, all right. So if Facebook wants to join, well, I mean, okay, great. So that's good, and I can't really say no, right? It's open, and but I already did some work with a student last year from a little university called Saint-Étienne in the south of France, center of France, and he had written a Google clone kind of. Google Plus clone before Google came out with circles and all in Java. Kind of, he had a notion of a graph. It was done in a couple of months. And what we worked with him is to port this last year to this, and it took him about another 2-3 months. So you can retrofit a system, refactor a system into the semantic web. You just need to. He had a graph where every arc was numbered with a number, really, right? So number 1 to 25, and or 1 to a string, hello, or Jack. So the problem with numbers is that if I send you something with a number 1, 2, how do you know what that means? Right? For me, 1 could mean name, my ID, and for you it could mean the sum. So this is why what you immediately notice as soon as you do. You start wanting to do a distributed information. You need to add URLs, and once you do that, so we just write the files to the disk. First, wrote the files to the disk very simply. Write RDF to the disk, and then publish it. And very soon, the whole logic of this came out. And at the end, the nice thing was that where at the beginning he was on his little social network with one person, at the end he could drag and drop Tim Berners-Lee, add him to his profile, and then we have a ping protocol so you could ping someone to say that you've added them to their profile. It's pretty simple. And so if you write your social network, you're not alone anymore. You already have a few million people with FOF profiles. And we want to make these FOF profiles even more useful than they are currently. So we want to make them interactive and dynamic so that when you add, so we don't have to, so currently I tell you how this worked in the semantic web world. You wrote your FOF profile by hand in BI. It's a very good exercise. And then when you've done it, you send your friends an email saying, can you add me to your FOF profile? And here's my URL. Of course, it only works if your friends also know RDF and can type it and have a web server. So that limited the number of users quite dramatically. And what we want to do is make it so that this is something as easy to use as the social networks that currently exist. Does that help you? Yeah? Oh, sorry, I shouldn't be saying who should speak.
You said just send them an email. Do you have ideas about how to do messaging over such a social network?
Yeah, so we had a really simple idea. You create a URL that's called the pingback relation. And in your profile, you could have something like your web ID, pingback, and some kind of container, like a form that people can post something to. And then people would go to that, know that if there's this relation, they can post you a message. And so they just do an HTTP post onto that container. It would create them a new resource, which would be a message, which might or might not be access controlled. And then clearly you would have on your side a user agent that would read this collection and tell you that you have a new message. It could do a bit of verification too, because it could find out the web ID of the user that sent this, find out his social network and say, well, there's already 3 of your friends who say they know him. So, that's a bit of confirmation. You can do these kind of things. So you just need to learn thinking in terms of posting graphs to some place and. So yeah. Go ahead.
Is there any possible collaboration between this project and Diaspora?
I'm sure there is. I spoke to the creator of Diaspora in Berlin 1.5 years ago, before he committed suicide. So I don't, and he didn't know anything about the semantic web at the time. So I'm not sure how. I'm not sure. Of course, if they start, if they start following this, then they could implement this in Diaspora. But it would mean that they need to move in to start thinking semantic web terms. I think that would give them a lot of more flexibility. And there might be many ways of doing that. It's just that I've been really keen to work with a very clean model of how you deal with data. So it's a bit of a pity that they tried to build a distributed social network without taking into account the 10 years of research or more in the space of distributed data. Because then you're just reinventing everything. So what happens is when people do that, they start hardwiring their system to certain namespaces. Then everybody has to have their personal profile at a certain slash. And I don't know how it works exactly. I didn't look at their stuff, but perhaps I'm wrong. But I'm sure any type of document can be represented as RDF. So you just need to write a transform, and I'm sure we could come to, if we work together, we could come to find ways of making these cooperate. Yeah.
Yeah. I wanted to ask about how you would aggregate such messages, and I think the first question really you already answered that. So that if in such a network you would have multiple people and multiple messages flowing to you, you would not have like one central hub to aggregate them, but have push messages from every node, from every server that is participating. So I guess my question was already answered.
So the fun thing is that the more you start thinking about this, the more you realize that all these Web 2 applications out there are all completely useless, right? I mean, you have, I don't want to be too not, but you have Foursquare to tell you where you are. To tell you where you are, you just put your profile at lat long relation for where you are, right? So there goes Foursquare. I don't want to be too strong here because they might listen to this and I don't know what happened. Like, I better, we go ahead.
about standards based? I mean, have you thought about the IETF and getting some standards behind this? 'Cause that's like, I mean, SMTP is a wonderful standard which we all know and love, and that's why it's so popular.
Yeah, so I'm at the, so for WebID, I went to Tim Berners-Lee about 5 years ago. I showed him this, said, this is cool. He said, yeah, very good. And he understood it about 1.5 minutes. And then slowly I realized that getting standards, we were working on a little mailing list, and then I started understanding why standard bodies are so important. They give you discipline. It took me a long time to understand the importance of the discipline of the standards body, even though I worked on them, on the Atom protocol. And so I went to we're at the W3C, but we're as an incubator group for the WebID. And we really need more implementers so that we can get enough people to say, look, why don't we make this a standard? And most of the work is done. I mean, we just need people to look at it and look at make sure the grammar is good, and have some good feedback from crypto people. More. But I'm really tired because I've been working on this for 5 years right now. So we've really worked it through. We just need to push this through the final door. And for that, really good implementations that work will be the best, I think. But definitely, we're basing all our stuff on here on W3C and IETF protocols, TLS mostly. And I'm not sure about, and if we do I2P, I'm not sure which standard body they're going through, or Tor. But if we could make this work with Tor, it'd be really funny.
Thank you. So if you have any more questions for Henry, he is right here. He will now go to the Media Cafe and will hang out with the people who want to discuss it offline. And there is also a workshop, I understood?
Yeah, here. So
okay, tonight at 8 in the Noisy Square. Yeah.
Yeah.
Okay.
Thank you very much.